Everyone. Today we're going to review area. And I say review because we've already touched upon this skill twice so far this school year. So let's review. What is area? Area is the space inside of a shape or object, and it's measured in square units. So if you remember, that space inside of the shape, there's two ways to measure it in the square units. We can count them, or we can use that fancy way of finding it using length times width if there are no square units to count. So again, let's review. Let's check out slide 4. So if you look on the left side of my slide where I'm circling, I would use length times width because there are no unit squares to count. It's not filled with squares, is it? It's one large area, right? I see a 7 on the top. I see a 3 on the side. And look below. It says 7 times 3, or my length times my width here. I'm going to multiply it. And it gives me the square units or the area of 21. If I look on the right-hand side, I see a bunch of square units inside. Do you see all the squares inside? So I could find the area two different ways in this particular shape. I could sit and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I could count them because it's already divided into 9 little squares. I could count them, but sometimes that would take a long time if I had a very large shape, right? Or I could simply go and say there are 3 squares on the top, or there are 3 squares long. That's why it is labeled 3 here. And there are 3 squares going down, or the width of them. And if I multiply length times width, 3 times 3 is boom, 9. And that's why we can use that formula of length times width. It makes it a lot faster, especially when we have a larger shape. You don't want to sit and count until you're about 90 years old, do you? So I have a quick video to remind you about counting unit squares, which we just did over here. And then we're going to do a quick practice on that. And then we'll do a quick practice using the formula length times width. And then we're going to do a tricky problem. Are you ready?
Today we are learning how to measure area. When I measure something, like this piece of string, I might measure its length. I could measure that it has a length of 3 units. But what about something like this square? Well, when I'm measuring the size of something like a square, I do it by using area. How do I do that? Well, if we take a look at this square, we could think about covering it with smaller squares of a set size. We call these small squares 1 unit square. Now we can see how many of these unit squares fit inside of our big shape. Then all we need to do is count up the unit squares to find the area. For this shape, we could count. It takes 1, 2, 3, 4, 5, 6, 7, 8, 9 unit squares to fill the whole shape. So its area will be 9 square units. Let's look at one of these together. Let's say we want to find the area of this figure. Well, what would we call each of these little squares? We call each of these little pieces 1 unit square. And how can we use unit squares to find the area of this shape? To find the area of a shape, just count the number of unit squares inside of it. How many unit squares are in this shape? Well, we could count all of the unit squares in this shape. If you did this, you would find that it has an area of 20 square units. Well, here's another problem to practice with. What is the area of this figure? Well, my advice when you're dealing with a complex shape like this is to break it into sections so it's easier to count. We could first focus on this green section right here. How many unit squares are in the green section? You can see there are 8 unit squares in the green section. Then we could choose to look at another section, like this one. How many unit squares are in the red section? You can see there are 8 more for a total of 16. Then we could count up this yellow section. How many squares in the yellow section? There are 8 more. And so when we put all of that together, we get that the area of this figure is 24 square units. Now it's time for you to practice on your own. What is the area of this figure? All you need to do to find area is count up the unit squares. If you count all of the unit squares in this shape, you will find that it has a total area of 25 square units. Now here's your last problem for this video. What is the area of this figure? This is a complex shape, so I'll break it into sections. In this green piece, I see 12 unit squares. In this red piece, I see 6 more for a total of 18. And in this yellow section, I see 4 more for a total of 22 square units in this figure. Today you learned how to find area by counting unit squares.
Okay, so that was a review on counting unit squares, but let's remember, not all shapes have unit squares broken into the shape. However, let's check out a few examples of when they do, so you can count them if you want to. So on slide number 6, just happens to have an example that's also labeled number 6. It says, what is the area? So we can sit and count. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do we see that option in our multiple choice? I do. And it's not just 12 squares or 12 pieces, it's 12 square units because each of them are a unit. Now, if you notice, I started up in the left-hand corner. Could I have started down here like he did in the video and went up? 1, 2, 3, 4, 5, 6. Sure, it doesn't matter as long as you remember where you started to count from and don't count the same square units twice. Then we'll be in a mess, right? You won't get the correct number. In this case, we ended up with 12 square units, and the correct answer was a part of our multiple choice. Now, check out slide number 7. This looks completely different, right? What a wild shape here. And we also don't have multiple choice. If I had this on paper in front of me, a trick that I like to do is use my pencil, my pen or my marker, and cross it off as I count it. That way I know that I've counted it and I don't recount it. But in this instance, I'm on the computer, right? And so are you. If you're working on the computer, always think to yourself, start in one spot and continue going in the other direction. That way you know you're not going all over the place. So I would not do something like this. I wouldn't start here, then go here and up here, because I won't remember where I have already counted. So for myself, I'm going to start on the left side, just like I read, and I'm going to continue going to the right. And then that way I know I won't count something twice. Are you ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. In this case, we came up with 13 what? What do we label it? 13 square units. You also know as I counted, I went from left to right, but each time I went from left to right, I went left and then I went to the top to the bottom as I was crossing things off using my mouse, right? I didn't go here, then I started the top and started the bottom. Always go the same direction and keep it consistent to help yourself. Now, I have another short video for you. Counting unit squares when the squares are there is always quite easy, right? As long as you cross them off, you know what you've counted because there's squares there to help you. Now we're going to review using that formula, length times width, after we watch this short video.
Today we are learning how to find the area of rectangles. Let's say you wanted to find the area of this figure. Remember, we can find area by seeing how many of these 1 inch by 1 inch unit squares would fill the shape. we could fill it up and see that this shape has an area of 15 square inches. But for rectangles, there's actually an easier way we can do this. Let's take a look at this rectangle. We could put down a first layer of squares, and we know that that is 5 unit squares. Then we could put a second layer down, that would be another 5, and we could put a third layer down, that would be another 5. Now to find the area, you might realize we just need to add 5 plus 5 plus 5. And this addition sentence is actually the same thing as just multiplying 3 groups of 5. And now let's stop and look at this for a second. 3 times 5. Notice that the 3 is the same as the 3 inches we have in our shape. And the 5, that's the same as the 5 inches. So to find the area of a rectangle, all we need to do are multiply the side lengths. We can multiply 3 times 5 and get the area is 15 square inches. We don't have to count any unit squares. Let's practice one of these together. Let's find the area of this figure. Well, how can we find the area of a rectangle? Remember, you can multiply side lengths to find the area of a rectangle. Here, we can just multiply 10 times 6. So what is the area of this rectangle? The area will be 60 square inches. Now here's another problem for you to practice with. What is the area of this figure? Well, how can I find the area of this rectangle? We need to multiply the 2 side lengths, so we'll multiply 6 times 3. What is the area of this rectangle? The area of this rectangle is 18 square inches. Now it's time for you to practice on your own. What is the area of this figure? This is a rectangle, so we can just multiply the side lengths. 6 times 4 gives us an area of 24 square inches. And now here's your last problem for this video. What is the area of this figure? This is a rectangle, so we can just multiply 12 times 1 for a total area of 12 square inches. Today you learned how to find area by multiplying the side lengths of a rectangle.
Okay, so we're going to use length times width to solve a few more examples. So check out slide number 9. It says Joey's shoebox has an area of 16 square inches. If the width is 8 square inches, how many square inches is the length? So now we have a missing number that I'm throwing in for you. So if we use length times width, we have the width, but we don't know the length. So I'm tossing in an unknown number for you. So if I have to multiply 8 times something, because now we don't have our unit squares here, do we? We can't just sit and count them. 8 times something. So that means I have to try every number in my multiple choice to try to get what? 16. So 8 times 5. 8 times 5. What is 8 times 5? That's 40, isn't it? 8 times 5. 5, 10, 15, 20, 25, 30, 35, 40. That doesn't give me 16. So A is out the window. So what is 8 times 4? 8, 16, 24, 32. 8 times 4 is 32. That doesn't give me 16, does it? B's out the window. I can't automatically choose C because what happens if they made a mistake? So 8 times 2. 8 times 2 or 8 2 times, which is really 8 plus 8, right? What's 8 plus 8 or 8 times 2? Does that give me 16? It certainly does. So 8 times 2, so if I kick out the question mark and put a 2 here, let's do it. Let's put a 2 there. From social studies, we should know how to make that box stand out, shouldn't we? Let's make it red. We'll beef that up, right? And put a 2 in there. Nice and bold, huh? Even bigger. How about that? 45. There it is. Is 8 times 2 16? It certainly is. So we found our missing number, and 8 times 2 makes our 16 square inches for the area of the purple box. Don't let a missing number scare you. How about slide number 10? Tommy's bed is 6 feet long. Here it is, 6 feet long and 2 feet wide. What would be the area? No missing number this time, right? But let's remember, what is that formula? Length times width. So it's 6 feet long, so 6 times 2 feet wide. Length times width. What's 6 times 2? Or 2 groups of 6. And if it's 2, it's 2 sixes, right? So 6 times 2 or 6 plus 6. I hope you said 12 because 6 times 2 is 12 or 6 plus 6 is 12. And is our answer there? It certainly is. So this yellow or golden box is 12 square feet. That means I could fit 12 squares in there perfectly. How about number 11 or slide number 11? It's question number 8 from the boxes that I took, but it's slide number 11. What is the area of the square? Now you're going to learn about squares, and you already have or should have. Let's remember that a square is nice and perfect. All sides are equal. So something's missing from this square if I want to use our famous formula, length times width. What is the area of this square? Length times width. I only seem to have one of them. I only seem to have the width here. I don't have the length. It's missing. So I'm missing over here. Let me beef that up and make it stand out. I seem to be missing my length here. What do we know about a square? All sides are the same. We have beautiful, perfect squares. If all sides are the same, what should I know about my length and my width? They should be the same, right? So if my width is 2 inches, my length should be 2 inches, right? I made it too fat, didn't I? So now that I have it labeled, because I remember that a square has all sides the same, my length and my width are labeled. So now can I multiply length times width? 2 times 2, 2 groups of 2. 2 times 2 is... Oh no, I see 2 4s there. I know 2 times 2 is 4. They're trying to trick me. 2 times 2 is 4. Which one is labeled correctly? I see inches and inches over here. I better make sure I choose C that says square inches, not square feet. If I chose square feet, I would be marked incorrect on my test because we're not measuring in feet, correct? It is inches over here. So be careful. We know those darn teachers try to trick you sometimes. How about this? Our very last question of the day here while we review. Now, what an odd shape. I want to teach you how to do this. You can find the area in an irregular shape. That means it's not regular. Check this out. Do you see that I have a red box here and a red box here, a blue box here and a blue box here? We're going to kind of play ninja here, and we're going to karate chop right in the middle. Do you see there's a dotted line there? We're going to karate chop this right here. And I'm going to match this blue box to this blue box. So do you notice where I have 8 inches here? This is 8 inches. That means the top is just as long, and that's 8 inches. And right here where I have 10 inches, that means over here is 10 inches. So do you think if I karate chop here and get rid of the red box, so ignore my red box right now, I only want to look down here where the blue box is. Do you think I could find the area where I am waving my mouse just in the blue box? I think I can. Can I use that famous formula to find the area with these two numbers right now, 8 and 10? So over here, let me beef up my font right now. Let's see if 30 is large enough for us. If I use my famous formula of length times width, right? Can I do that? Let's go ahead and do that. So what would it be? Can I do 10 times 8? What would 10 times 8 be? 10, 20, 30, 40, 50, 60, 70, 80 square SQ inches, right? Ooh, spheric. Ooh. 80 square inches. Okay, so my blue box, the area we found is 80 square inches. Did I find the red box yet? No. Remember, I ninja kicked that red box and I karate chopped it off. So now we need to just find the red box. Can I use the 4 inches and the 3 inches to do the same for just the red box? We certainly can. So let's do it up here. So what would my formula be up here? Let's use 4 times 3. And what is 4 times 3? 4, 8, 12. So up here we would have 12 square inches. Well, we don't need all this space now, do we? Perfect. So the red box is 12 square inches. The blue box is 80 square inches. Do you think I'm done? Because I want to know how much area this whole black shape is together. And if I use that word together, what do you think I should do? Right now I have a red box, a blue box, but I want to put them together to see what the whole black shape would be. I hope you said I should add. So now I'm going to come over here to the orange box because I would like to take my 80 square inches and then I want to add the 12 square inches to the 80 square inches. Oh, it doesn't always look super pretty on the computer here, but that's okay. I want to add those two together, right? And what do you think I should get? What is 0 plus 2? 2. And 8 plus 1 is 9, right? So 92 what? Chicken butts? Gooey boogers? 92 square inches. I hope that's what you said. 92 square inches. There we go. 92 square inches is, I'll make it red so it stands out for us. 92 square inches is the total area of the black figure. So if you check out the red shape here is just 12 square inches. The blue shape here is just 80. But if I put them both together, I get 92 square inches. We made it easier for ourselves by sectioning this piece off and this piece off because this rectangle was easy to make 80 and this square was easy to make 12. And then we could just add the pieces together because this is an irregular shape. Then we could just add the pieces together. Sometimes you'll have that. Sometimes there'll be easy shapes like this square or this rectangle, even though it had a missing number. But sometimes you're going to have odd or irregular shapes like this. And it's just like a puzzle where you could cut a piece off, find two different areas, and then add the answers together to find the total area. Don't forget to label your answers properly.